So this video is on implicit differentiation, and it's intended to help you find the equation of the tangent line for the circle x squared plus y squared equals 16 at x equal 3. So if we just take a look at what this circle would look like, we've got a radius of 4. So we'll go out 4, up 4, out the other way 4. My circle's not going to be very good. But I think you'll get the idea. So we'll make our circle orange. All right, so it can be really tough to draw on this pen pad. However, what we're looking for is the equation of this line that's tangent to this circle at that point x equal 3. So we're looking for the equation of this line right here, that green line. What is that thing? Well, we know that the equation of a line looks like this. And we already have some information that we can use right here. So we're going to have our slope. We don't know, but we do know our x value is 3. Let's go ahead, before we do any calculus, let's go ahead and find out what that y value is. To find that y value, I'm going to go in and I'm going to replace x with 3. So y squared would be 16 minus 9, or y squared is going to be 7. Excuse me. Throw an extra equal sign in there. Y squared is going to be 7, which means that y is going to equal plus or minus square root of 7. So there are two actual tangent lines here that we've got to be aware of. One of them is up here. The other one is down here, right? I probably didn't see that one coming. That was kind of out of the ordinary. You may have noticed that when we were graphing it. Isn't there another place on this circle where x equaled 3? So I need to work my problem knowing that there are two solutions. One of them is where this y value is going to be the square root of 7, and the other is where the y value is going to be the negative square root of 7. Equals, and again, we don't know the slope, but we're going to find it. All right, so I'm going to let that soak in for a minute. I'm going to go close my door, and I'll be right back. All right, so you've had a minute for that to soak in. Let's go in now and see if we can't find what the slope of our tangent line is going to be. And in order to do that, we're going to need a derivative. So let's go in and take a look at what our derivative here would be. So we'll just kind of block that off. We're going to take the derivative of x squared, which is 2x. Now, when we take the derivative of y squared, we're going to have 2y dy dx. And then the derivative of 16 is just 0. But really, the reason we're throwing the dy in there is because we're taking the derivative with respect to x. And so when these variables do not match, I have to put the dy dx here. The reason I don't put dx dx right here, I don't put 2x dx dx, because dx dx would just be 1. So we'll go in and see if we can get the dy dx by itself. We'll begin by moving the 2x to the other side. And now I'm going to divide both sides by 2y. So when I do that, dy dx is going to equal negative x over y. The 2's cancel out. So we have two lines. One of our lines is when we're dealing with the positive square root of y. So our x value was 3, and our y value was this. We can simply leave our slope as negative 3 over square root of 7. But we also have another line where our slope, where our y value is negative square root of 7. So if we do negative 3 over negative square root of 7, a negative divided by a negative is a positive. So our other line has this equation. So if we kind of recap, our first step was, let's draw this thing and see if we can't get a picture of it. That way I kind of have an idea of where I need to go from there. The next thing that we did was we found our y value. We found our y values. In this case, there are two y's that we had to find. The third step was take a derivative. It's a calculus class, and so if you're not taking a derivative, you're not doing it correctly. That's one of the things that we want to make sure we do. And then lastly, we just plugged our information back into this standard form for that point slope form for the equation of our line. I hope this video was helpful. If you have more questions or if you need any additional help, please feel free to reach out.